Stop blindly accepting your GCP health check defaults. I just helped a team reduce their incident response time by 40% by tuning a few settings, and I'm going to show you exactly how to approach this for your specific workload.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm Alex, and I'm here with our resident cloud expert ready to dive into something I've honestly never thought much about.
Great to be back. Today we're getting into the weeds on GCP health check configuration, specifically those threshold settings that most people just accept and forget about.
Okay, so I'll admit, when I set up load balancers, I usually just accept whatever defaults GCP gives me for health checks. Why should I care about tuning these thresholds?
Here's the real-world pain. Your backend instance starts having intermittent issues, maybe a garbage collection pause or a brief network hiccup. With default settings, GCP might pull that instance out of rotation too quickly, or worse, leave a truly unhealthy instance serving traffic for way too long. I've seen production incidents where a single misconfigured threshold turned a minor blip into a 15-minute outage.
So we're basically talking about how quickly GCP decides an instance is dead versus alive?
Exactly. Let me break this down. In GCP Cloud Load Balancing, when you create a backend service, you attach a health check resource. That health check has two critical threshold settings: unhealthy threshold and healthy threshold. The unhealthy threshold is the number of consecutive failed checks before GCP marks an instance as unhealthy and stops sending traffic. The healthy threshold is the opposite: how many consecutive successes before a recovering instance gets traffic again.
So if my unhealthy threshold is set to 2, and my health check runs every 5 seconds, an instance could be marked unhealthy in just 10 seconds?
You're connecting the dots perfectly. The actual time to detection equals your check interval multiplied by your unhealthy threshold. Now, I should mention that GCP's defaults can vary depending on whether you're creating health checks through the console, the API, or GTL, so always verify the current defaults in the official documentation. But typically you'll see both thresholds default to 2 with a 5-second interval, which gives you that 10-second detection window. And here's where it gets nuanced. You also have a timeout setting. If your health check request doesn't get a response within that timeout, it counts as a failure.
Can you give me an analogy to help me think about this?
Think of it like a security guard doing rounds in an office building. The check interval is how often they visit each floor. The timeout is how long they wait at each door before marking it as unresponsive. The unhealthy threshold is how many times they find a door unresponsive before they call it in as a problem. Now, here's something important. GCP actually enforces that your timeout must be less than or equal to your check interval. If you try to configure a timeout that exceeds your check interval, GCP will reject that configuration outright. The system won't let you create that invalid setup.
That makes sense. So what values should I actually use?
It depends entirely on your application's behavior. For stateless microservices that should respond quickly, I typically recommend a check interval of 3 to 5 seconds, timeout of 2 to 3 seconds, and an unhealthy threshold of 2 to 3. This gives you detection in 6 to 15 seconds. Now, keep in mind that GCP allows intervals as low as 1 second, but very aggressive health check settings can increase load on your backend instances, so there's a practical balance to strike. For heavier applications with occasional garbage collection pauses, you might want an unhealthy threshold of 5 or even higher, with a check interval of 10 seconds. That gives the application breathing room during brief hiccups.
What about the healthy threshold? Does that matter as much?
Absolutely, and this is where I see the most mistakes. The healthy threshold determines how quickly a recovering instance rejoins the pool. If you set it too low, like 1, an instance that's flapping between healthy and unhealthy will keep getting added back prematurely. I recommend a healthy threshold of at least 2, often 3 or 4 for critical services. This ensures the instance is genuinely stable before it starts receiving production traffic again.
What's the biggest mistake you see people make with these settings?
A few things. First, using HTTP health checks with a path that hits their database or external dependencies. Your health check path should be lightweight, something like a simple status endpoint that returns a success code without touching external systems. And by the way, GCP considers any response in the 200 to 299 range as healthy by default, and you can actually configure that range if needed. For gRPC health checks, there's a specific health checking protocol to follow.
What about applications that take a while to start up?
Great question, and this is critical. A lot of people think the healthy threshold handles cold start time, but that's actually a different parameter entirely. GCP health checks have an initial delay setting, called initial delay sec, that specifies how long to wait after an instance starts before beginning health checks. This is the primary mechanism for handling cold start times, especially with managed instance groups. If your application takes 30 seconds to initialize, you should set that initial delay appropriately, not try to work around it with threshold settings.
So let me make sure I've got this. The unhealthy threshold controls how quickly we remove bad instances. The healthy threshold controls how carefully we add recovering instances back. The initial delay handles cold start time for new instances, and all of these need to be tuned based on my specific application's behavior.
Nailed it. And here's my pro tip. Use GCP's cloud monitoring to track metrics like loadbalancing.googleapis.com/https/backend_latency_distribution alongside your health check logs. This helps you correlate threshold changes with actual user-facing performance. Start conservative with higher thresholds, then tighten them as you understand your application's normal behavior patterns.
This is super practical. I'm definitely going to review our health check configs tomorrow.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone managing GCP load balancers. This stuff matters more than people realize.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.